We are now going to discuss how the CPU processes. The fetch execute cycle. So a program which is a set of instructions designed to make the computer perform in a particular way is executed by fetching each instruction in turn from the computer's memory, decoding the operation required, and then performing the required operation under the direction of the processor. The control of program execution is exercised through the processor's automatic sequence control mechanism. The activity is also known as the fetch execute cycle. This will be explained further towards the end of this presentation. The theory of von Neumann states that a processor consists of three hardware subsystems. Firstly, the CPU, or central processing unit, which can be viewed as three subsystems: the control unit, the ALU, and registers. The main memory, which holds the current program that controls the computer's operation and holds data needed or generated by the current program, and the input-output system, which transfers data between the system and the real world. In order to complete processes, the processor uses data called a memory word. A memory word is the contents of a memory location, namely pure binary, coded binary, for example binary coded decimal, and character codes, for example ASCII. All of the above are considered to be data and can be interpreted as such by the CPU. But in order to perform any tasks, it has to have access to computer instructions. During processing, data currently being processed and the instructions needed to process the data are stored in main memory, RAM. Thus, a memory word can also form an instruction, in which case it is referred to as an instruction word. One form of data is known as a data word. Any given processor is designed to handle a particular number of bits as a unit, typically 8, 16 or 32. The size of this unit is known as the processor's word length. A processor with a word length, for example 32 bits, uses that unit size during the execution of arithmetic, logic, data transfer or input-output instructions. In addition, any working registers within the processor are also equal to the word length of the processor. The current maximum word length is 64 bits. Processor registers. The CPU has a number of registers, which it can use to temporarily store a number of words read from memory. These registers are used to apply meaning to memory words. It should be noted that memory words cannot be determined as being data or instructions simply by examination of the code. The CPU differentiates between data and instructions by locating instructions in an instruction register and data in data registers. The process of fetching, interpreting and executing instructions is called the fetch-execute cycle, but may also be referred to as the instruction cycle or automatic sequence control. The fetch-execute cycle involves the use of a number of registers, special storage locations within the processor. A computer program stored in main memory comprises a sequence of instructions. Each instruction is transferred in turn into the CPU's instruction register to identify the next operation the CPU is to perform. The instructions are retrieved from consecutive memory locations unless the last instruction executed requires the next instruction to be fetched from a different location. Instructions dealing with the latter circumstance are called branch or jump instructions. The fetch-execute cycle. The image on screen shows the format of the fetch-execute cycle. It involves a number of discrete steps. 1. The contents of the PC are copied into the MAR. The MAR now contains the address of the next instruction to be fetched, and a memory read is initiated to transfer the instruction from memory into the MBR. 2. The PC is incremented and now contains the address of the next instruction. 3. The instruction is transferred from the MBR into the CIR. 4. The instruction in the CIR is decoded and executed. 5. Unless the instruction is a stop instruction, then the cycle is repeated. The algorithm used during this process is displayed on screen.